All right, it's 10 o'clock, so it's time to start this little session slash webinar, Samuel. Thank you for everyone for joining this session called Securing Windows Provisioning in 2025. And we will speak about F12 and images and all that good stuff, won't we, Samuel?
Yes,
No,
we will.
those times are almost gone, fortunately and unfortunately at the same time, I guess. But let's speak a little bit about Windows 11, because that's where our heads have been at for some time, right? So Windows 11 is supposed to be, secure by default, and we have this good old secure future initiative from Microsoft stating that hey, everything is secure by default, and it's also an initiative to make fill the gaps where stuff is not as secure as intended, maybe. And I just wanted to point out some figures here. It's really good to see like a sentence like, hey, security drop, because otherwise it's always the other way around. A security increase, security breaches and everything. So this figure does actually show that we are doing a good job in securing our devices. And of course, the 62% is in comparison to Windows 10 devices. And this comes with, there's a lot of reasons for this, of course. We are getting more and more aware. We are doing a good job in educating our users. Do not click on shady links and stuff like that. But also stuff is actually being enabled by default as part of the Secure Future initiative in Windows 11. So I just wanted to point this out. It's always good to see something positive, I guess. But before we get this show started, who are we? Well, my name is Niklas Sahlberg. I'm from Sweden, the south part of Sweden. So I guess could almost call me a half Dane. Especially if you ask my good colleague here, Samuel.
Yes, my name is Samuel, and I work together with Niklas in the Secure Client team, and I represent the capital in this meeting, Stockholm. So with that, what do you say, Niklas? Should we get started?
Yeah, let's go. So Autopilot V1, and yeah, we will stick to V1 and versus V2 just for if we have someone new on the call here that doesn't work with Autopilot. It's getting all the new names and stuff is getting hard to follow. So let's start with V1. And if you're not into Autopilot as of yet, let's have just a really quick overview on what's happening, what to expect, and how this actually works. So we receive a device. So that's step one. We plug it into our network. So we might want to use a cable or Wi-Fi. So network connection, that is still a thing, right? In order to get our devices onboarded. Then it's actually going to, during OB, it's actually going to connect over the air, over internet, the Autopilot service. And it's going to ask the Autopilot service like, hey, am I managed by a specific organization and tenant? And if yes, am I supposed to do an Autopilot enrollment, yes or no? Of course, if we have uploaded a hash ID, hash value to connect this device with our tenant, it's going to download the Autopilot profile. It's not the same as a task sequence, but just to kind of paint the picture, it could almost be compared to one, almost at least. Then we need to authenticate. We need to prove that we are allowed to enroll and onboard this device to our tenant. So we will do so with our Entra ID credentials. The device is going to join Entra. And as you can see here, yeah, we are talking about Entra ID join. We are not talking about covering a hybrid scenario, which is not recommended by anyone, I suppose, but definitely not recommended from a user and admin perspective. It's doable, but please do consider doing Entra ID join instead. Then it's going to join and onboard to enroll, to Intune. This is where the happening is, or the magic is starting to happen. So it's going to install policies. Then it's going to go ahead and run scripts if we have any. And then it's going to install applications, and it's going to take us through the ESP for us. So that is kind of like really quickly what's happening here. And for the hash, as you can see here in the green, we do have the download profile. And I did mention a hash to kind of connect our device with our tenant. We could either connect it ourselves by extracting and uploading the hash, or we could ask our reseller, device reseller, or OEM to do it for us. And the latter one is definitely the one we do recommend in this scenario. So if you are into OSD, if you're not using Autopilot as of yet, you may ask yourself, hey, when do I install my image? Where does my image come into this scenario? And it kind of does and doesn't, because Windows Autopilot does not install an image. The image is already supposed to be installed on the device. And that's the perfect segue into Windows Images test and verify scenario. So as I did mention, we need to test and verify, and also sorry for this image, it's in Swedish. But as you can see here, something went wrong. The red exclamation mark is a good indication that, hey, something is not working. And as you can see here to the top right, it's a weird icon, weird box, a weird button. And this is actually a picture from Windows Update on a specific device. In the ISO of Windows 11 2025-04, as in April, we were actually introduced to a known issue, or it became a known issue, where some components of the Windows Update component doesn't work. So it's basically 100% corrupt. And if you found yourself in this scenario, as you can see here from the first image here, we have something that Microsoft pushed to us in 2025-08. This is in August, right? So let's paint the picture here. In 04, as in April, Windows Update went corrupt. And then in 08, we were introduced to a repair version for it. But how do we apply a repair version of Windows Update when Windows Update is corrupt, right? And if you had a look at this time, you had a look on forums and articles and stuff like that, they were pointing against what you can see here down to the bottom here, fix problems using Windows Update. Okay, so I can fix my Windows Update problem by using Windows Update. So basically, we were in a pretty bad state, right? So, and with this version of Windows 11, we need to be able to catch this. We need to test and verify before we actually proceed with using a new image. And if we, as the IT department, on our organization, apply the image by ourselves because we want to have a custom image, we need to test and verify. Otherwise, we need to make sure that our reseller or OEM does this work for us. Otherwise, stuff like this could definitely happen. And we saw this with a customer or a couple of customers actually, where it's always nice to have the latest ISO. Unfortunately, it wasn't tested enough, so they went corrupt. So and the only way to actually fix it was by using Windows Update to fix it, because that's the recommended version, because you could actually do like a in-place upgrade, right? So if we click on the fix problems using Windows Update and then we click on the reinstall button here, what's going to happen is it's gonna go ahead and use Windows Update to download the fixes for us, and then it's going to do an in-place upgrade to repair Windows to the same version of the Windows we are currently at. So far so good, but we cannot use this when Windows Update is corrupt, right? Because it's depending on that. So what we went ahead and did instead, we created a Windows 11 recovery package, and this could be like a good thing to have as a backup plan if you are into Windows Autopilot. And by doing so, we downloaded a fixed ISO, like in May, I believe we started with. So the 2505 version of Windows 11. And then we exported the Vim file from that one, that ISO, and we compressed it to, because the only thing we need from that ISO is the recovery mechanism and binaries, right? So we can create something that's called an ESD file instead. There are some good articles on Microsoft on how to do this if you want to learn more. And then we uploaded this. We wrapped it as an app, and we pushed it through Intune. And as you can see here in the middle, what's really important is to remember to put dynamic update to disable, because otherwise it's actually going to use Windows Update to download the latest version for us. But as we already did that in the ESD file, we didn't need to do that. And also, if dynamic update is not actively disabled, it's going to be enabled, and this is going to fail because Windows Update is corrupt, right? So we cannot use the dynamic update functionality. So ISO and images is still a thing, but it's more about testing and verifying before we actually allow our OEM reseller or ourselves to actually start using them. We just need that good old stamp, like, okay, hey, this is actually working. We are good to go with a new version. And of course, BIOS settings are also pretty important, right? Because when it comes to the supply chain, we are allowing our reseller to install and do stuff to our devices before it's sent to our users. So it's always good to have the BIOS settings part of our installation as soon as possible. And for Dell or any other manufacturer / OEM for that matter, they have some really good possibilities in doing that for us. So what I would recommend is use the PowerShell version. If you're using Dell, do use PowerShell, wrap your settings as an app, and then just go ahead and add that app as a blocking app during the ESP to make sure it's blocking. So unless our Dell settings for BIOS is actually correctly applied, it's not going to allow our user to start working otherwise. So that way we know that, hey, it's up to code, BIOS settings are okay, and now we are ready to start working with this device. And of course, again, this is just an example for Dell, but we do have the same possibilities with other manufacturers as well. And before we start, we actually need to make sure that we are in a good place in terms of hardware, because the hardware is kind of it's where everything starts, right? So we all know about Windows Hello for Business, but in August, of course, these things are always happening either during Christmas or any kind of holiday, or during midsummer. For some reason, that's when everybody has more time, I guess, to exploit things and do some deep research on security features that we have been using for some time. But with this, a researcher actually revealed something that they called Windows Hell No for Business instead, meaning that they were able to, by being local admin on a device, they were able to extract the bio, like a facial information from a device, and then import it to another device and sign in as another user by showing him or herself in the camera. So this is pretty scary, right? A prerequisite in order to be able to do this exploit is admin on both devices. So there are still some layers of security to go through before this exploit can actually be implemented. But still, it's something to worth mentioning. And the only way to stop this was to use enhanced sign-in security for Windows Hello for Business. And enhanced sign-in security comes with a lot of hardware requirements. So even though you are on a Windows 11 capable device, there might be some hardware requirements that you are missing out on to be able to use all the Windows 11 security features fully. So definitely make sure that the hardware you are ordering to be used with Windows 11 and Autopilot are supported on all your requirements in terms of security features, right? So basically, enhanced sign-in security means that it's going to use VBS to store the biometric data, and because it's another security layer, it's away from the OS kernel, so it's not going to be allowed to extract it, that data, even if you are local admin on the device. So that's how you would secure it. But still, enhanced sign-in security, that's a tongue twister, is definitely something we would recommend that you make sure your devices are supporting of. And it starts before provisioning, doesn't it, Samuel?
Yes, it does. Thank you, Niklas. So the securing starts before provisioning. Let's see here. We have the Shift F10 during OB, and Shift F10 has been part of the Windows setup for decades, intended as a troubleshooting shortcut. However, in modern Autopilot provisioning, that same shortcut could become an attack surface. And out of the box, nothing in Intune or Autopilot blocks it. So the question becomes, how do we harden a device at its most vulnerable moment? From a security perspective, Shift F10 during OB gives unrestricted system access before enrollment. From that shell, you can create a local admin, modify security settings, alter execution policies, and more. And all of this happens completely outside of Intune and Entra ID. And once the device enrolls, controls like BitLocker, Defender, and baselines will apply. But by then, the machine may already have been tampered with. So that's why blocking Shift F10 before enrollment is increasingly prominent in today's secure provisioning. Now let's take a look at how we can block Shift F10 and the methods to enforce it. Windows setup includes a built-in control for disabling command shell access during OB. When the file disable cmd request.tag is present under C, Windows setup scripts, Windows setup will automatically disable all command shell access, including Shift F10. So this file is created manually, it doesn't ship by default, and the name is case insensitive, so any variation will work. And there's no hacks, no registry edits. This is a supported Windows setup behavior. So if that file is present, it will work. But the challenge is persistence. Resets recreate Windows setup environment, whether it's a push button reset, autopilot reset, or a user-initiated wipe. And that process clears the setup folder, removing the tag file and all other contents. So after a reset, that means Shift F10 will have become re-enabled. So how can we ensure persistence? We have reset-config.xml, which is a Microsoft-supported way to customize what happens after a reset. By placing it under C recovery OEM, we can hook into that very recovery process. And in our case, we have paired it with a small helper script, the create shift f10 block.cmd, that will recreate the setup scripts directory with the tag file inside. So together, these two files, the XML and the helper script, ensures persistence. So even after a wipe, autopilot reset, or a push button reset, the tag is automatically reapplied so that Shift F10 will stay locked. To operationalize the solution, we have wrapped the free files into a Win32 app. So the app contains both the tag creator and the persistence logic. We chose to deploy it as required in Intune and mark it as enrollment status page required during autopilot pre-provisioning, as you can see in the screenshot. And with pre-provisioning, that is the recommended flow, because in those cases it will install the Win32 and guarantees that Shift F10 is disabled before the user ever interacts with the device. And optionally, OEMs can pre-stage these files inside the image, so devices ship with Shift F10 already blocked before they even join the tenant. Moving on, we can summarize the measures that protect every stage of the enrollment and beyond. So first out, we have hardening before enrollment. During OB, as you know by now, there's a vulnerable window before any security policies apply. Autopilot pre-provisioning lets us close that gap by applying protections early, before the user ever touches the device. And this is why we deploy the Win32 app marked as enrollment status page required. And next, we can reduce the blast radius if tampering is attempted. The key here is once again the tag file deployed early via pre-provisioning, and it blocks Shift F10 before enrollment begins. So while it removes a troubleshooting option, the trade-off is worth it to close the main pre-enrollment attack vector. We can also enforce standard user enrollment so that the enrolling user is created as a standard user at the first sign-in. And we can also configure reset options to be hidden in company portal. And this ensures that users don't see or trigger reset actions. And with strong upfront controls, post-enrollment monitoring is still essential. A key signal to monitor could be unauthorized local admin creation. With Windows Labs and Intune proactive remediation, we can automate the response. For example, we can use event 4721 to log a new user. Detection picks it up, and remediation disables or deletes the account. So this gives us a continuous protection, even if someone tries to bypass the initial hardening. So in summary, these actions, hardening early, limiting tampering, and monitoring continuously, gives us a layered protection across the full device lifecycle. We will take a super quick look at the security gap we're closing. This is a fresh device I will show you at the very first OB screen. At this moment, nothing is enrolled, nothing is protected, and pressing Shift F10 launches a system-level command shell. From that shell, creating a hidden local admin takes seconds, and we have no authentication, no telemetry, and nothing to monitor it. It seems to be pausing a bit, the video. And we can see here that the account has been created, either by a creative user or a bad actor. But what about if we what if we apply our recommended fixes? We will now start Autopilot pre-provisioning. Windows applies the Autopilot profile, and enrollment status page kicks in, and all the required apps and baseline install. And among them, we have our Shift F10 blocker. So by the time the device reaches ready to ship, it's already in a hardened state, and Shift F10 is disabled before a user ever touches the keyboard. So now the device can be handed over to the user and boot into normal user OB mode. And if the user were to press Shift F10, nothing happens. No shell, no privilege escalation path, and no tampering. So this will give us a predictable, tampering-resistant starting point.
Yeah, perfect. Thank you, Samuel. And it all comes down to the risk acceptance, right? So if we cannot live without the Shift F10 functionality, we definitely need to make sure we have all the security measures in place to cover and monitor those scenarios that could happen during the supply chain. So I'll go ahead and share my screen back, and let's speak a little bit about what could happen during Windows Autopilot v1. We have something that's called the unexpected reboot, and a lot of people actually think that it's supposed to reboot unexpectedly during Autopilot v1, and this is probably it's definitely the first thing we look for when we start with a new customer, and do some troubleshooting for Autopilot. It's really, really common, and we have found a way out there to actually live with this scenario. But Autopilot is not only about security, it's also about a seamless user experience. If we have an unexpected reboot, users must re-authenticate after the reboot, which is, not convenient. And it's also going to break the passwordless experience, because during the reboot and boot up, it's going to throw away your passwordless token. So you would need to redo all of that. And what we have seen with customers is actually that due to unexpected reboots and due to the fact that IT think that this is supposed to happen, like it's part of the design for Autopilot, users tend to not use passwordless experience because it's just too much. It's not convenient enough. So definitely check for those. And a good tell, if you cannot do some troubleshooting, dig through log files and stuff like that right now, one thing you could do is check for the flow. A good tell is that if the user is presented with a sign-in screen after ESP is done, and not directly giving the opportunity to onboard to Windows Hello for Business, if that's a thing on your company, Windows Hello for Business would be the next step after the ESP. Or if you're not using Windows Hello for Business, you would you would need to be signed in directly into the desktop to start working. If that is not happening, your device were probably suffering from an unexpected reboot. And the unexpected reboot basically happens because we push some settings down to the device, and we push it to the device setup phase during ESP and not to the user. So these are the settings we would need to look up for. And as you can see here, security baseline. And this is probably the main bad actor, I would say, in this scenario, because with the security baseline, it's a baseline, right? It's a set of security settings, and it includes a lot of the other stuff that we have here on the list. And we push that down to the device, the Autopilot device, and that is 100% 100 times out of 100 that is going to generate an unexpected reboot, unless we actually kind of divide and segment those settings away from the security baseline and push it down to the user instead. So drilling down a little bit more into this, a little bit more technical, but on a specific per setting level, these are the specific settings that will, if these settings are applied on the device during ESP and during the device setup phase, it's actually going to trigger an unexpected reboot for you. And what do I mean? Well, if you have never seen Autopilot or the ESP, the unexpected reboot will happen during the device setup and the device setup phase if it's pushed down to the device object. So what we need to do is put it on the account setup phase instead. And by doing so, there will be no unexpected reboot happening. So this is great. And from an admin perspective, what we need to do is figure out which policies are actually managing the settings we just had a look at, and then push it down to a group that contains the user object instead of the device object, right? So push it down and assign it to a user group instead. And here is one way, if you're able to have a look at a device during troubleshooting or in the initial phase of Autopilot project, we would need to have a look at the event viewer. This would be the path. We would filter down to 2800, and as you can see here in this case, we had six events with this ID, but all of them are not, necessarily triggering an unexpected reboot. The next thing, once we have found some of these events, is to have a look at the timestamp, because as you can see here, we have 43 minutes between what's in red and what's in above it, right? So the other 5 is probably during the user phase. So those were not responsible for the unexpected reboot. However, the one here were during the device phase. And as you can see here, we have the manage preview builds, and that translates to one of those settings that we were supposed to look out for. So now we just need to find a way to kind of identify which policy we're pushing this down to the device phase, and then just push it down to the user instead. So that's enough V1. We have something new that is called Windows Autopilot device preparation. We will call it, for the duration of this session at least, we will call it V2 because it's pretty easily going to be mixed up with pre-provisioning. So when we speak about device preparation and then sometime during the line we mention pre-provisioning, we tend to lose the customer. Like, hey, what are you talking about? Isn't that the same thing? No, it just sounds the same, basically. So V1, V2 is much easier to use, even though it's not necessarily the next version of Autopilot. So one main one main difference is that we're not using hash IDs anymore. So that's great, right? And no reason to upload a hash ID. Just a little bit easier for us as admin and so on. But there are some caveats as well. It does not support pre-provisioning. So that's something to keep in mind, because a lot of the security things that we would like to push down to the device could be done, or will most likely be done, during pre-provisioning in V1, right? So if you are transitioning or looking at migrating over from V1 to V2, please keep in mind that pre-provisioning is not a thing in V2. There are no group tags. If you have that in place in a current environment, there will be no way to use group tags, because those are part of when you upload a hash, right? So in not having to upload a hash, we will also lose the group tag functionality. And we're not using the ESP anymore. We are, however, using the native built-in OB. And as you can see, it's dependent on Windows 11. There is no hybrid join for V2. So if hybrid join is still a thing at your company, there will be no hybrid join with V2, unfortunately, or fortunately, maybe. Yeah, it's crucial. So because we don't use hash upload or the hash ID to kind of match this device with our tenant, we need something else, right? So there is always something else, I guess. So what we're using instead is called corporate identifiers, in order for us to match this device with our tenant. And the first thing I would like to highlight while looking into V2, this is what we would like to see for the default platform restriction policy. We definitely don't want to allow any personally owned devices to enroll to Intune, because that's one way for a bad actor to get a foothold into your device estate, right? Maybe circumvent compliance and conditional access and stuff like that. So we do want to block that. But what we see with customers is that when they try to test V2, they would actually start allowing personally owned Windows devices, because otherwise it's going to be blocked, right? But the fix here is, do not continue to have these settings, definitely continue to block it. And then, yeah, and this is what it's gonna look like to fix this error. Like, hey, you are not supposed to do this because you're trying to do a personal device enrollment, because there is no way of us to figuring out whether this is a corporate device or not, because we are not using the hash ID, right? So the fix would be to create another platform restriction policy. And in here, we are going to allow personally owned devices for Windows. And we're going to push it down, as you can see down here, to do not, this is just for my demo/lab environment. Don't do all users. You probably want to scope it to a user group that are actually allowed to use Autopilot V2. And then we're going to create a filter with this or similar to this query and rule. And then we're going to apply the filter to make it a Windows corporate devices. So if a user uses a corporate device, then they will be allowed to enroll the device as personally, and then in the back end, it's going to kind of magically mark it as a corporate device. So the corporate identifier is basically a free, it's a CSV file that you upload with a manufacturer, as you can see here in red. In this example, I'm using a Hyper-V virtual machine. So manufacturer would be Microsoft Corporation. The model, device model in green is a virtual machine. And then you have a long serial number. This would be, if you're using HP, it would say HP and your model, maybe what I know, ProBook generation 5 or something, and then the serial number. So you get the drill. And once that has been done, you will be allowed to upload it on as a corporate device identifier. You will find this blade on the Windows enrollment blade in the Intune portal. And then the experience is gonna look like something like this. Let's see if we can start this video. So we'll sign on, we'll do some MFA magic, and this will be the new experience. And yeah, I don't know, it's something else, I guess. I'm not sure I like it more than the ESP experience, but I guess this is the new thing. So yeah, and part of the magic of a pre-recorded video, it's going to jump directly to 100%, and then this little page will be presented to let us know that, hey, everything is fine, you're ready to complete the setup, or we are done to complete the setup. The user is allowed to sign in and start working, basically. So pretty neat. So that's a really important thing when it comes to Autopilot and V2. Definitely do not open up for personal enrollment in the default profile, because that's, you know, one way in for a bad actor to get a foothold in your device estate. There is always a solution, right? So, but let's have a look at some news. There are some pretty cool news out there. So the first thing we would like to mention is that with Windows 11, 24H2 and a specific KB, as you can see up here, we're actually allowed to do something that's called an initial start menu. And this is also pretty good and pretty great from a user experience, because we will pin icons on the start menu that we believe that our users would you know, like to see there. But if they don't, this the JSON file is applied as an apply once to true, as you can see here in the red circle, meaning that it's actually going to allow the user to change it. So it's no longer a static start menu, like what you see is what you get. The user is allowed to change it accordingly, which is of course good for everybody. And with that, another new thing, and I will invite Samuel to have a look.
Thank you, Nicholas. Some more news. How can we remove modern apps with a new method? What we can control non-essential Microsoft Store apps that ship with Windows. Things like gaming components, consumer tools, or preview features. And these might not be critical for enterprise use. And remove them can help standardize the device baseline. The current approach many organizations use is Apex removal scripts. They do work, but they can also be sensitive to change. And that could mean that results are not always consistent, and there's some maintenance overhead. With Windows 11 25H2, a new OS level method for this is introduced. Remove default Microsoft Store app packages. This moves app removal into the provisioning pipeline. So that's great. However, there are, of course, still some considerations that apply, and it's not a blocking control. Users can reinstall apps unless restricted through a separate policy. And guaranteed support is currently available only for Windows 11 25H2. If you take a look at this, enabling the setting in Settings Catalog delivers a native MDM policy, the App Package Deployment CSP. And the policy is evaluated during provisioning. And removal occurs at the following occasions, which is during OB, when the user signs in after an OS upgrade, or when the user signs in after an update to the policy. Windows writes everything under HKey local machine, remove default Microsoft Store packages. We can see here in the screenshot, we have a package-friendly name for each and every application. We have clipchamp and things like that, and they have their own subkey, as we can see. And if that subkey exists and the policy is enabled, Windows will unprovision the corresponding app during provisioning. Intune currently exposes only a curated list of removable apps in the settings catalog UI. However, Windows will remove any AppX package whose package-friendly name appears under that registry path. So on this device, on this example, I have added tips and Windows maps for a custom script. And both were removed even though they weren't available for selection in the settings catalog. And we have event 762 here that confirms the on-provisioning of Windows maps and logs exactly what the OS processed. So that means you can remove copilots, LinkedIn, OEM apps, and a provisioned AppX, even if Microsoft hasn't exposed it in the UI yet. So in summary, this feature is a strong addition, but the exposed app list and customizations options are currently limited, but with the potential that more will be added over time. So if the apps you need to manage are already supported, you can simply use the settings catalog and the fully supported method. And if you need deeper customization, you can instead push the package-friendly names through a lightweight script, as we did with Get Started or Tips and Windows Maps. So this is how we can manage and remove modern apps in a supported way. Now that we have hardened the device during provisioning, the next challenge is identity. The problem, provisioning usually breaks at the identity step. A new employee receives a device, but they can't meet MFA requirements because MFA isn't set up yet. That's the identity bootstrap problem. You need MFA to sign in securely, but you can't set it up until you have signed in. TAP can handle this cleanly. It provides a short-lived scoped credential that the user can use exactly once, if configured, to complete their first sign-in and register their real authentication methods. And to get the best balance out of usability and security, TAP should only be valid briefly. It's an onboarding tool and not a long-term authentication method. Let's walk through TAP in practice, how we can enable it and how it fits into provisioning. So we can see here that TAP is configured under Enter ID, authentication methods, and temporary access path. To modify this configuration, you need Authentication Policy Administrator, Privilege Authentication Administrator, Global Admin, or a custom least privilege role. And that's the recommended approach. Minimum permissions for issuing credentials. And under these settings, here's where we define the operational rules such as lifetime, single use versus multi-use, and target scope to either users or group. If you check issuing a TAP to a user, here I am at the user's Enter ID profile under Authentication Methods, having clicked Add Authentication Method. Selecting Temporary Access Pass shows several settings already predefined from the tenant configuration. For example, single use is locked if you have configured it tenant-wide. And also we can see here we can configure things such as duration and start time, either if you want to activate it immediately or if you want it starting at a future moment. So after generating the TAP, Entra displays the one-time passcode. We still need to deliver this code to the user, but because TAP behaves like a token, it's short-lived, scoped, and non-replayable, it can be safer than distributing a normal-ish temporary password. And once TAP is issued, Windows Autopilot will present TAP as the sign-in method during OB. And as we can see here, how it integrates. So at OB, they sign in with the temporary access pass and enter their TAP code. And as soon as the TAP is redeemed, it becomes invalid immediately if we have configured it as single use, ensuring it can't be replayed. At this point as well, Windows issues the user's first primary refresh token. And the primary refresh token enables things like conditional access evaluation, device compliance checks, and access to enterprise resources. So the PRT, primary refresh token, can serve as the core identity bootstrap, establishing the authenticated trust. And once the PRT is issued, the user can register authenticator or FIDO2 keys. So TAP is not simply another login method. It's a secure time-limited credential that enables initial onboarding and supports a smooth move into modern authentication, directly addressing the identity bootstrap problem from day one.
Perfect. Last thing for today, we'd like to just briefly touch down on using Windows 365 as a vPAW, and when will we do this? Well, it's way better than doing nothing. So when it comes to PAW privileged access workstations, we always want to see physical devices and as the end game, kind of like the final boss, I guess. But the path to do that could be really long and time consuming. And because Windows 365 is so easy and quick to set up, it could make sense. So instead of doing nothing in terms of PAW, we could actually use Windows 365 as a temporary solution for our vPAW devices. So the thing when it comes to provisioning those, because this is the theme here is secure provisioning, right? There are some things we would like to highlight. So Windows 365 basically comes with two sets of images. Either you choose and pick the one with Office package pre-installed. And when you do that, you will also get some Teams optimizations. And some of these things, the optimizations, are actually documented. But a lot of scripts will run on these devices, these gallery images, so we don't actually know about them. So we need to think about, do we really accept that for our vPAW devices, right? So do we accept the risk over convenience in using the gallery images, which is basically just like a choose and pick kind of deal when we set up and configure our vPAW devices. What I would like to highlight is the importance of actually taking that control back and doing custom images instead. We are not going to cover how to do that, but if you're using vPAW and Windows 365, definitely have a look at doing custom images so that you can take back some of that control, because these are the really sensitive devices, and we need to know exactly what's happening on them. Maybe at some point Microsoft will start documenting what's happening exactly on the gallery images, but at this point they will just shine a little light on each scenario, and it's not enough for a vPAW. With that, of course, if you're doing Windows Autopilot already, or if you would like to have a look at it, definitely contact some of us over at Onevinn. We do a lot of assessments, as you can see here. You will find this on the web page as well, on your current setup. Is it up to code? Do we see and identify any security risks, or are we ready to actually start going with our configuration? So security setup assessments is definitely something that is kind of happening as of today, I would say. And with that, definitely please do stay in control or get in touch. These are mine and Samuel's mail addresses. You'll find us on on the mail or on Teams. And with that, we'd like to thank you so much for listening to us these like 55 minutes. Time flies when you have fun, right? So enjoy the rest of your day and have a good one. Thank you for attending.
Thank you.